Hello guys, in continuation with my previous topic of digital electronics logic gates, in my previous video, I'll just give you a link in my description box for that video, and you can check down for the first topic related to this video. In continuation with the gates, we just discuss about what are basically gates. Okay, in gates we have discussed in our last class that what are different types of gates, and we have discussed the different types of gates are OR, NOR, and XOR, XNOR, and NOT gate. Okay, so we have discussed to make it easy and a NAND gate. Today I will tell you three more gates, very important gates. First is the NOT gate. Now, as the name suggests, I'll talk about the NOT gate. As you would be able to make out from a NOT means the reverse. Okay, that means if I take any variable x in my previous, please I request you again that do check my previous video also guys. You would be able to understand how we make the table depending on the different variables. And I told you one important thing to remember is that if we are having the n inputs, the total number of outputs or combinations, we can say we are having 2 to the power n. So if we say we have one input, we have two combinations. If we have two input, we have 4. If we have 3, we have 8. How we come 8? 2 to the power 3 is 8. 2 into 2 into 2. 2 to the power 3 is 8. And 4 we have 16. And so on. If we are having n inputs to generalize, we have 2 to the power n combination. So this is very important point to remember in the digital electronics. Now coming back to a NOT gate, let's take one variable. I also told you that how many variables we can take. Now suppose I take a variable name as x. Now I want to say this x is having a value of 0. Okay, and we say we have discussed. So if we have one variable, then that means we have two out combinations possible. So we have one variable, two combination possible. मैं फिर से बोल रही हूँ एक वेरिएबल दो कॉम्बिनेशन 0 and 1. Okay, so we'll take the output. Now NOT gate reverse the value of the input. So whatever value we are having, please don't get confused क्योंकि इसमें थोड़ा सा I'll just make it again for you all how NOT gate works. So this is my NOT gate. I apologize for the kind of writing I'm having here. I'm not so used to of making a good handwriting out of this. So okay, so we have x, one variable, two combinations possible, and computers only take inputs in form of 0 and 1. So we say one variable and two combinations are possible. The reverse of this, we take a bar. That means the value gets reversed. So the value of 0 will become 1 and the value of 1 will become 0. This is a simple NOT gate. Now let's try and make this is my table, and now let's take how does it behave. Now if we want to reverse any function, what is the usage? If we want to just reverse, okay, so we always take this as this is the circuit diagram for a NOT gate. So we have x variable, we have output as my x bar. Okay, so this is my AND gate. Now moving on to the OR and NOR gates. Okay, I hope you have understood this part, and let's move on to that how my OR and NOR gate works. In my previous video we have discussed AND gate, and we just talked about that a simple multiplication works in AND gate, and in the same way addition works in OR gate. So when we say an OR gate, we are trying to say or emphasize that what is an OR gate. That means, now again let's try and take two variable table. Now I hope you are able, after watching my first video related to digital electronics logic gates, you are able to make a two variable table for OR gate. Now two variable, Again, I repeat, 4 combinations possible. So let's first make the 4 combinations possible. 0, 0, 0, 1, 1, 0, and the last combination possible is 1, 1. Okay. So we have 4 combinations possible with 2 variables. Now, how does it behave? If we define it as any function f, so we say this is as x plus y. Okay, so this is my OR gate, and this will behave as a simple addition. Now, simple addition, how does it work? So we say 0 plus 0 gives you 0, 0 plus 1 gives you 1, 1 plus 0 gives you 1, and 1 plus 1, remember, it doesn't give you 2 because 2 is not a binary number and computer only understands binary. So students generally do this mistake, 1 plus 1. 1 plus 1 can never be a value of 2. The computer will only move to the next value, that 1 plus 1, with, if you take an OR gate, and if you take 2 inputs as 1 and 1, the output will be 1. Remember this. अगर हम दो वेरिएबल को इनपुट कर रहे हैं और गेट लगा रहे हैं तो हमेशा हमें 1 मिलेगा, क्योंकि कंप्यूटर सिर्फ और सिर्फ बाइनरी इनपुट्स ही लेता है, जो कि है 0 और 1. Okay, now let's try and make the logic diagram for this OR gate. So this is my OR gate. Now try and understand how we make the OR gate. So this could be like this. Somewhat like, oh, I'm so sorry, I'll just make it again for you all because it should, gate should be properly made. I'll try to be more artistic with you all. Okay, I'm so sorry. Okay, this is how you make. I request you to please do check it in your books also for this. So this is my OR gate. I take as input x and y, and my output is x plus y. So we say if we have 2 inputs as 0, 0, we'll get output as 0. If we have 2 inputs as 0 and 1, we'll get an output of 1. If we have inputs of 1 and 0, we'll get an output of 1. And if we have inputs, the last possible combinations, if we are having the value of 1, 1, we are getting output of 1. Simply we can say AND gate have 3 inputs as 0 and 1 output, and OR gate has only 1 output as 0, rest are 1. So we say if any of 1 exists in input of OR gate, we always get an output as 1 because OR is logical addition. Okay, again I repeat, this is a logical addition. Now moving on to NOR gate. So simple, as we have discussed that NAND is an opposite of an AND gate. Similarly, the NOR gate is an opposite of an OR gate. So we'll try and make we just extend this table, and we try to extend this table by just putting up a opposite function, that is my NOR gate. So we say x plus y. So f bar is equals to x plus, I apologize students, what I'll do is I'll just drop this side also. I hope you must have understood what actually the logic diagram. So now here I'll try and make this table much better for you all to make it understand. Okay, once again I apologize for my drawings, friends. Okay. Now, so now here it will be the opposite NOR. That means my function gets reversed. Okay, my function gets reversed meaning क्या होता है? Okay, what is the meaning when we say the function gets reversed? So first try and make this NAND gate. So this is my, NOR gate. This is my OR output, and this is my NOR output. I simply put a bar on it, and we have already discussed in my previous video that how the bar works. So we'll get the output of function using OR gate, will get 0, so this get reversed 1. 1 will get reversed as 0. 1 will get reversed as 0, and 1 will get reversed as 0. So this is the NOR. Okay. Now, if you want to make a logic circuit for a NOR gate, so simply we first make an OR gate and we simply put a bubble, a small bubble. So a bubble always represents a NOT gate. We have discussed this just in this video only, that NOT gate. So if you signify a simple triangle, that means it gives you the same output. If suppose now I'll just try to explain you that if you take this circuit, see the difference between these two circuits. If I take this circuit, this X is my input, then X only will be the output. That means if I put this only triangle, so if my input is 0, I'll get 0. If my input is 1, I'll get 1. Now NOT gate, how does it work? We simply put a bubble in front of a triangle, then it becomes a NOT gate. So if my X is 0, it gets reversed 1. If I get X as 1, it gets reversed as 0. Okay, fine. Now coming back to my NOR gate, this side, I'm talking about this. So in this NOR gate, we have two variables, X and Y. The OR gate says X plus Y, and the bar function gives you the value for the bar function gives you the value for a NOR gate. Okay, so we say that OR and NOR gate, how does it behave? Okay, so this is a bubble. This represents that the output, the whole output gets reversed. Please make it very sure. I'll explain you that what is the difference between a bubble putting before this gate or after, what is the difference that we try and locate in De Morgan's law. Through that we are able to identify the De Morgan's law also. So that's all for this video, guys. We have discussed about NOT gate, OR gate and NOR gate, the table and the logic diagrams. And in my upcoming video, we'll discuss about the very important gate, and these gates are also known as the fundamental gates also. Okay, so exclusive OR gate, XOR and XNOR. Okay, thank you so much, guys.